houses and others. So that's important to understand. So mainly we'll discuss what multi-source data analysis is, what are the challenges, and if time permits, we will talk a little bit about how we do it in Python. Okay. So essentially, our goal, or people who are in the bootcamp, are here to understand data analysis. So this discussion is about where data is stored. So data can be in a single file, or multiple files, or even across different systems. Some analysis may be based upon a single input and others on multiple inputs. So you have to have some strategy to make sure that you understand what it means to collect or use data from multiple sources to do your analysis. So this is mainly due to data being collected and managed in multiple ways, but they all need to be used for analysis. And this is very common. I'll go over an example of one of the dashboards we developed where we had to collect data from 6 or 7 different sources to do our analysis. So let's consider an example. So again, I'm using an example that you're familiar with. So students, apply for admission. That is done on a portal. That data goes into some database. Students get admitted, have UTA ID, email, etc. Students register for courses. Course grades are added on a semester basis. Fees and other payments are also recorded. Resident hall and other information may be available. So these are different types of data on the same students that are being collected, but you cannot assume they're all going to be in one place or one file or one DBMS either. So all the above cannot be in a single file or even in a single database. It's also not the case that all information is needed for every analysis. So data needed depends on the analysis being performed. And so you have to identify the data that you need, sources where it comes from, understand the data, and then perform the analysis. So analysis of data can be done at several levels. Again, I'm giving some examples that you may make it easier to relate. Students may want to look up their course registered, wait list, payment status, etc. Instructors have a different need. We want to know how many students have registered, whether a class is full, where it is held, what are the background of the students who are enrolled in the course. Those who are doing class scheduling and room assignment needs different type of information. They need to know what are the tools that are needed, whether you need a projector, whether you need a recording system, how many seats, when it is met, and all those things. Chair of the department needs comparison of sections in which course the students are not doing well, so he can take whatever action. Dean is interested in performance of students across departments, genders, increase, decrease in student enrollments. University president is interested in knowledge that is relevant to the whole university, funding levels, demographics, domestic, international participation, etc. So the reason I've listed this is that analysis requirements are not the same for every user or every player. So remember, we talked about views. You can look at each of them as a different view, a student's view, an instructor's view. It uses not only different information, it protects other information from being used by people who are not authorized to use that. So this is very important to understand. This can also be done across universities in a country, within a country, or across educational institutions in selected countries. So, so uh, for mining, so one observation is that for mining, most of the algorithms use data from files in a specific format. So that's how sort of mining algorithms have been developed and are still used. So they assume data. So if you look at the Python packages, for example, you have to transform the data into a particular data structure that particular algorithm uses, and not all algorithms use the same data structure. As the data size increases and data needs to be staged from disk to memory, this becomes a problem. If you have a file system and an algorithm that works on files, this staging of data has to be done managed by the application. So if you use a file system, then you have to worry about that, as I indicated earlier. But this was the reason why DBMSs were developed and optimized for data staging and concurrent access. So why were not these algorithms developed on a DBMS? So that's a very important question and an insightful question. And the only answer I can give is these things were developed by two different groups. The group that was developing a DBMSs was not the same group that was developing mining algorithms. So there was not much interaction between these two. But at some point, people realized that there is an issue because you have to take the data out of a DBMS if it is stored in a DBMS and then feed it to it. So IBM at some point came up with a solution. IBM developed a mining system, a product that they marketed called DB Miner that would use data directly from the database. They used their database DB2, but it could also use data from other DBMSs. Prior to this, data had to be siphoned out of a DBMS to run a mining program, not only siphoned out, but converted into the format that was expected by that particular mining algorithm. So you could run most mining algorithms using data stored in relations using the DB miner. You could even combine relations to get required data. So it is possible that the data in a relational DBMS is stored across different relations. And if you want some columns from this relation, some other columns from this relation, and a few columns from a third relation, you could first do a join, which is very easy to do, and then run the mining algorithm on that. Now, I think the kind of the interesting thing is that this DB miner became so popular, IBM started bundling its DB2 as part of it. So they were selling DB2 separately, and DB2 itself was quite expensive. DB miner as a mining platform running on DB2 was also quite expensive, and because there was such high demand for DB miner, they started bundling parts of DBMS into that so that people can store their data. So kind of this is just to show that why what is the effect of having data in multiple sources, multiple places in multiple formats, and how it affects. So mining and analysis may also need data from multiple and even heterogeneous. What I mean heterogeneous is one data may be in the relational database, another data may be in a file, a third data may be in a network database. So these are not only different sources, these are heterogeneous sources as compared to all the data being in a relational DBMS, which makes it a little bit easier to integrate them and run the program. So to combine data, technical advancements have simplified the process of combining data, storing it, and making it accessible to business users. So this is not only for analysis, but you also need in other places like generating queries and other things. So if you remember, data warehouse was one of the ways in which data was integrated, data was combined for a specific purpose. But here we are talking about a general purpose. So integrating data from multiple sources is the key to having a data-driven organization and opens a range of possibilities involving self-service analytics and business intelligence. So this should not be very hard process or complicated. May involve refining data into a standardized format and creating a new repository, because not all the data sources may be using the same standardized format that is needed. Duplicate elimination may also be involved if a source is known to generate duplicates. So Oracle sort of has defined these three categories of multi-source data usage. You can think of it as data integration versus data joining versus data blending. They all do something similar, combining data from multiple sources, but there are subtle differences. So what is data integration from that point of view? It is the systematic, comprehensive consolidation of multiple data sources using an established process that cleans and refines data. So for cleaning and refining data, you can use any of the ETL tools that we mentioned earlier: extract, transform, and load. So there are a lot of different tools that are available with different capabilities. They can be used as part of this data integration. They are often consolidated into a standardized format. When this cleaning is complete, data is loaded into a repository such as a data lake or a data warehouse. Transformations and integration are often handled by data curators, data scientists, or other IT staff. So this is very important to understand that domain knowledge is needed for data integration, because you need to know what sources are needed for analysis. Not everything from every source is needed for analysis. You have to pick and choose. And then you have to bring it into a format that is conducive to the analysis package or the analysis algorithm that you're using. So knowledge of the format of the tools used is also very important. So you need domain knowledge, you need format of the tools. So data blending is similar but slightly different, the process of combining multiple data sets into a single data set for now. However, unlike data integration, blended data often combines native data, that is data that has not been transformed or cleansed, from multiple sources. For example, an HR team will use blended data if they combine the current quarter's internal hiring metrics with an open source data set from the government on hiring trends. Unlike data integration, this example requires the user to clean and standardize the data after it is blended. So here you're using not all the data from your sources in one format, but you're using open source public data. So that just requires that you blend the data and then do the standardization and cleansing and other stuff. Data joining is more straightforward. This is essentially joining tables or relations within a DBMS by applying the join command using SQL. So like data blending, data join involves combining multiple data sets. The difference is that joining requires that data sets come from the same source, or at least have some overlapping column between them in order to do the join. To expand on the HR example above, data joining occurs when the HR professional takes government sourced national hiring metrics from the current quarter, then also downloads the quarterly data from 4 years ago for comparison. So kind of then you can combine these two because they have some common columns. These data sets come from the same system and use the same format, but need to be joined based on specific data ranges. So kind of you can think of it as the three different ways. So I think what is important here is not that you have to combine data. You have to understand how you combine data. What are the things to be considered in order to do this integration, depending upon where the data is coming from, what the formats are, and how you are combining different data in different formats. As we said, there are several ETL tools for data cleaning, fixing formats, etc., needed for data integration or facilitate multi-source data usage. This is a huge industry because data is never clean. Data has a lot of missing values. Data has a lot of duplications. I mean, one good example I have come across is these agencies that maintain your credit card information, Equifax, TransUnion, and there is one other agency. There are three agencies, and the data, is not clean. They had a lot of issues initially because the same person's name was spelled in three different ways in three different places, and they could not figure out which one is which. Same thing with the address. So there are a lot of discrepancies in the data that needs usage. Otherwise, you are showing wrong information or information that is not correct. So this is a very huge industry, extracting, transforming, and loading. Traditional rule-based and now AI-based techniques are being developed and used. So tools use different techniques. Very rarely, data from multiple sources are in the required final format. That is true. So here are some examples of the ETL tools. I will not go into the details, but looking at, IBM has a tool, Oracle has a tool, Microsoft has a tool, indicates the gravity or the severity of the situation, why these teams are needed. AWS has a flow. So this is very important, even though it's not as complicated as analysis, but still it's pretty complicated to make sure that you get data into a good format. So analysis using multiple data. So as far as I know, there is no prescribed way to handle data from multiple sources. There is no way that you can say here is one way to handle all types of data sources. What is available are guidelines and some of the challenges that are faced while dealing with data from multiple sources. This is certainly not an easy task. Requires understanding of the data domain, requirements of analysis in order to combine or prepare data for the purpose of analysis. So this is something still there's a lot of methodology that is evolving based upon different things. Statistical methods have also been used for combining data from multiple sources. For example, is it possible to fill missing data? What kind of distribution to be used? What kind of distribution is appropriate? Because there are a lot of missing data in the real data world. Predicting linkage information. This is another issue which has a lot of research saying, how do we predict linkages between data sets when it's not available? What are the challenges? So certainly data quality and consistency. So quality is very important. So you have to understand whether your data is accurate, complete, and consistent. Because if you use data that is not accurate, your analysis is not going to be good. Data transformation for integration, transformation to a common format, what tools to use for what kind of cleansing and modification. Data security and privacy are very important because data is secure and compliant with relevant regulations governing each data source. So different data sources may have different security requirements, different regulations. So In one of the modules, you will look at licensing, for example, whether the data source that you're accessing has the appropriating licensing and what kind of licensing you use also becomes important for them. And of course, whether it's a public data versus private data. Confidentiality, access control are also important. Data scalability and performance are important because if you are combining data from multiple sources, the data volume is going to increase. And with increase in data volume, you need to make sure you are able to handle that information in that. So unfortunately, a lot of analysis algorithms that you'll see when you use the packages. So one of the things I've seen is, for my data science course, I would give the students a large data set. And some of them would come back and say, sir, we cannot load all of this data in our laptop because our memory is limited. We have only 32 GB and we cannot load all the data. And all the algorithms that you use in pandas and others are main memory algorithms. They only work on the data that is in memory. So I had to ask some of them to reduce the data by taking the sampling and other things and run only that portion of the data because the algorithm does not support staging of data, does not access a DBMS. So there are certain limitations in terms of what is the current status of the technology to do the analysis that you want to do. So response time is another issue when data scales. The other issue that's also equally important is incremental analysis or incremental computation. So if you have done analysis up to some number of years, you add one more year of data. Do you have to redo the analysis for the entire data set from scratch? Or can you do an incremental analysis that is correct? And incremental analysis is always very challenging. Sometimes you cannot do it, sometimes you cannot do it. So in order to manage data from multiple sources, first, you have to identify your data sources. Are they structured data, unstructured data, are they graphs, are they images? Then you have to import your data into your preferred tool or environment, whether it's Python or R or SQL, it doesn't matter. Explore your data, meaning you understand your data, get a sense of quality, quantity, and characteristics. Some statistical genetic checks can also be performed. So, for example, if you have graph data, you can get some graph characteristics. Even if you have numerical data, you can get some distributions. You can get mean, average, standard deviation, and other things. Clean your data. Deal with null values, deal with missing values, misspellings, duplicates, normalization if necessary. And then combine, integrate as needed, determine what to combine based on analysis needs, analyze your data and interpret your data. So analyze your data means that you want to extract meaningful insights. For this, you may use statistical, machine learning, data mining, graph analysis, whatever tool that is appropriate. Visualize and interpret your results. So this has becoming more and more popular because of the size of the data sets and also makes it much easier. So you can generate reports, tables, and visualizations as needed. You can use charts, graphs, map. Some formats may be easier to understand than other kinds of formats. To summarize, analysis using single source that is complete and understandable itself is a challenge. On top of that, if you add multiple sources with all additional issues, is certainly something that needs to be approached in a principled way using proven tools and techniques. Both domain understanding and analysis approach requirements need to be used diligently in order to do this successfully. So I wish I could give you more detailed steps, but these are kind of the guidelines as to how you need to deal with that rather than individual steps that you can use. So what I want to do is to sort of give you a feeling of how we dealt with it for one dashboard developer. So I don't know how many of you played with this dashboard. I had given this as the evening activity on Monday for you to play with one of the dashboards that is available for the COVID analysis that we have. Today, I'm going to discuss a little bit of the second one, and today's evening activity will be using this with the understanding that it involves a lot of different data sets from multiple sources. But one good thing is here the sources were not very complicated, did not involve any images and other complex spatial things, except we are using US map from Google. So when we started our COVID data analysis, so it's kind of this started at the beginning of the COVID. We were thinking, we were looking at various websites that were giving information about COVID, but all of them were giving kind of just showing the raw information graphically, nothing more than the raw information. So that is still true. So a lot of times you just see the raw numbers displayed visually. So our interest was on, doing this with respect to counties. There are about 3,000 plus counties. So that is the sort of the granule that you can think of. Spatial granule is a county. So, each county decides or discusses, what they want to do in terms of various things. So counties with maximum minimum number of cases, deaths, recoveries, tests. So that is statistical visualization of raw data at the county level, because the information can be gathered at the county level. Temporal aggregation, analysis and visualization, regions with maximum rise decline in daily cases in the periods pre and post vaccination drive or lockdown. So you can take temporal ranges and show what is happening in temporal ranges, event-based aggregate analysis and video. So here we are coming to more aggregate analysis that is event-based rather than temporal. Regions that got significantly affected due to major events like July 4th, Labor Day, Memorial Day, etc. So this was true. One, people were looking at increased in COVID cases after a holiday break. And there were a number of ways that one could explain it, but this was observed very routinely. We wanted to see that's true. Parameter-based aggregate analysis and visualization. So populous regions more susceptible to the virus spread due to the presence of institutions which large workforce and heavy. So other type of analysis is when certain companies or institutions, or places where there are a lot of enterprises with large populations working, how does COVID COVID cases change? Or if once people start moving, in cases where they are mobile, they go from one county to another county, how does it change? So kind of these are the things that we wanted to address. So for the event analysis, we chose the following. So I'm explaining. So when you go to this dashboard, it's easy to. So we have a base period prior to the event, number of new cases form the basis for computation. So for example, if you take, this is a Thanksgiving weekend in the US, so you can choose a period before Thanksgiving. So let us say November 10 to November 18, 19th, which is a 10-day interval. You can also choose a target period, which is after the event. So you want to compare how things changed with this interval or with this event coming in between. And target period size is the same, 10, 10, so it is a fair comparison. And then equal period in 10 days. So this is how we formulated it. And we also formulated it on counties. So we used a research analysis methodology for this, which is typically not used, known as the multi-layer network. So we represented each county as a node of a graph. So you have a graph of 3,000 plus nodes, and we connected an edge if counties have similar percentage change in the number of new cases in the target period as compared to the base period. So the similar percentage is within the range that's indicated. So county communities, geographical regions with similar needs we took what is called the communities. So we compared detected communities in this graph and then showed it. So severity rate was, if there was no change, it is flat. Then there is a decrease. There is a downtick. There is a big drop. Similarly, on the other side, you have an increase, uptick, and spike. So these are the different colors used for representing it. And the final visualization comes like this. So what does it mean? What it means is for this event, the red ones are the ones where there was a spike in the cases, new COVID cases, and the green and other colors have less increase. So you can see that some regions had a much higher spike compared to some other region for the same weekend. And it may be dependent upon the population. For example, it may be dependent upon the kind of restriction that particular state or county had in place at that time. So you can correlate to these things in some way. So this is the dashboard that we wanted to develop. So in order to do this, we had to identify data sources. So I think last time I had asked you to play with this one, animated timeline. So this one does not do any analysis. It just does what we call the descriptive analysis, where it just shows the raw data in different ways, easy to understand. Whereas this one does an analysis based upon some algorithm and then displays it, and you can also hover over the county to see more details. So visualize regions with similar changes in confirmed cases around an event of interest. So you can see that these were the lot of different data sources were used. I have more details of them. So we had to, for this one, we had to collect data, do the pre-processing, and do consolidation. So some of the issues I mentioned had to be handled for doing this. So data is not in one place, multiple participants, entities, features. So, you have one source that may give you positive cases, one source that may give you deaths, recoveries, hospitalization, tests, vaccinations, demographics, location. So this is what a multi-source data analysis looks like. This is in the context of COVID. It may vary for others. So if it is single source, it makes it easier. If it is in a single format, it's good. There is no merging involved. Multi-source means different information about the same entity provided, but so there has to be some common entity to merge them. If there is no common entity, there is no way to merge them. In our case, we had that in terms of the counties and county numbers, potentially multiple formats, selection and merging. So here are the places where we got the data from. So from CDC, this is the one in Atlanta. We got positive cases, deaths, tests, hospitalization, and recoveries. From OWID, I'm not sure what the expansion of that. We got vaccine doses, people vaccinated as number percentage, daily trips by distance data from the US Department of Transportation, stay longer than 10 minutes away from home, anonymized data, mobile devices, population staying at home, number of trips, daily mobility reports, visits, and length of stay from Google. Other sources, which I don't think we have used it, but you can use restaurant occupancy, census, daily tweets. I think this we used. Spending categories, this we did not use. I think we had difficulty. So you can see what is the difficulty involved in doing something with multiple sources, right? So you have to deal with so many different types of data. So pre-processing challenges. So data file format, delimiter, comma, tab, value format. What kind of values can you accommodate? Numeric, text, location, which is mostly specified as lat long. Different attribute formats we have to deal with. In some places, the date is in this format. In some other locations, it is in this format. Temperature may be in 2 different units. Measurement units, name may be different. Some places it is like this, some places like this. So this is the code that is used. Missing attributes that may not be applicable, that may not be recorded. So from multiple input files based upon which common column attributes to combine. That's one thing here, this is similar to what we do in joins, but these data is not in a database. They're coming on a daily basis. For each day, you get a separate file. Then you have to merge that file to the previously available file, doing all the processing that you want. Which columns to shortlist? Not every column, because all this data has 20, 30, 40, 50 columns. Not all of them are interesting that we want to use. So merge data file for us. So we took luckily, all the files were coming in as CSV files, but they had different pieces of information, some common information, some different information. So we used state and date as the joining attributes, and then we collected all that information into a common file. So this is how we decided to merge this data on our own, because we had to write a piece of script to do that, because if it was in a DBMS, we could have just run a join command to do that. So complete detail of, so I'm not going to go through that. So if you want, you can click on these and go to the places where we have collected. So this is collected by our world in data. So these are different places where it collected from. So snapshots of input data points. So here is a little more, a few rows of information for this. So US state vaccination, 2,800 plus rows, 14 attributes. This is 20,000 rows, 39,000 rows, Google mobility data. So need for a configuration file. So one place to change all requirements. So again, there are different ways in which you can deal with it. One way is to just plunge into it and then handle it. But if you think about maintenance and extension and adding features, what you want to do is to have some kind of a metadata that will help you do that. And that typically is done as a configuration file. So one place to change, if you want to change your requirements, you will do it in the configuration file rather than in your code. Avoids hard coding, paths, constraints, input parameters, ease of specifying data parameters. So you can specify input data file path, attribute format, what columns to use, what data rows based on conditions, and what columns to transform. Can easily handle and merge multiple data files. So here is a sample of the configuration file that you used. So for each source, so total sources 4, and for each source, we have given a bunch of information that is read by the script used for merging. And this is a sample merge file, merge COVID data for US states, 14 attributes. So this is for this page. So the other thing that you need to worry about is whether the data is static or dynamic, meaning if the data is changing, and new data is being added, then you have to worry about how to deal with that. If it is static data, then you merge it once you are done. If it is dynamic data, then you have to worry about how to merge, whether do it incrementally or you do it in some other way. What are the issues? So as asynchronous updates, every source can potentially have different frequency of updates. So one may be updating at 2 a.m., another may be updating at 4 a.m., one may be doing it daily, one may be doing it weekly. So you have to deal with that. Automated web crawl to collect some of the data updates. So for this, we use what is known as a cron tab, which is something that you can set in a Linux environment to schedule at a specific time of the day to specific things. Parameterized on-demand calls for external APIs. For example, if you want to fetch news related to COVID for a particular interval, then you can parameterize. This we needed because we are giving base and target periods. So we also wanted to make sure that the dashboard architecture is modular. In other words, it's easy to extend and add things. So at the client level, what the user sees is user interaction component and display. That's all you see at the client end. At the back end, you have a bunch of things. You have pre-processing, layer generation for our analysis, base data processing, analysis one. So you can add additional analysis components as you progress. So doing this architecture in a modular way is extremely important. All the data is stored on disks in a file. Live data is obtained as and when needed from the web sources. And then there are some optimization things, visualization is done. I will not go into the details of that. Okay, so this is the demo. There is also a YouTube video, a 5-minute video that we have posted, and you can play with the demo. So I'm going to stop this module here. I think you have seen that. I can show you the demo, but your evening activity is to click on this, I'll come to that at the end of this series. So because I don't want to. Okay, evening activity. Go to this URL. There are 2 dashboards to play with. For COVID dashboard, click here. So that is the one which has 2 components. Click on the US map. So that is the one we are looking. This shows analysis of COVID data using multi-layer networks and multi-data sources. You can choose 2 intervals, base and target, of the same size. That's automatically enforced. So once you choose the interval and once you choose the start date, the interval is automatically determined. Of the same size, separated by whatever number of days you want. You are trying. So you can try 2 things. One, where there is no event happening like long weekend or holidays and things, and one where the event is happening to see the difference between them. So you can choose 2 intervals, choose the first interval first, choose the base date earlier than January 2023, as we don't have any data on COVID beyond this point. Choose the target date, select severity rate, click submit. What you should see is a US map in which each county, there are 3,000 plus counties, change over the gap is shown using a severity level. You can hover over the country to get county demographics. For example, you can get the population of the county, mean income rate, mean education rate, and other things. Ticker showing real time information from World Health Organization. So this is another thing that is also not very easy to do because you have to get data in real time and then store it like a ticker symbol for the stocks. So the homework for you is, as you know, some states had severe COVID restrictions as compared to others. So we know that New York, for example, had a very strong restriction compared to Texas or Montana. It is interesting to see how things change in these states. We also know that COVID cases shot up over long weekends. So you can visualize that by choosing your base and target across these validators. So just play with it and see what we are looking at is a finished product, but developing that involved multi-source data input, merging them, cleansing them to some extent, doing some analysis underneath, and then visualizing them in a particular format. So that's what analysis is about. Okay, so this brings us to the end of this module. I'll be happy to answer any questions you may have and then move on to the next module. Okay. Can you see? Okay, I have stopped sharing. Let me share it again. Okay, can you see my shared screen? Yes, no, yes. Okay, thank you. So this is the last module today. I hope to finish within the time, maybe plus or minus a couple of minutes. So let me just recap. So what I have done as part of this bootcamp is to talk about data and analysis, data and storage and data management. Then we talked about multi-source data need and the challenges for analysis. And now we are looking at interoperability. In addition to this, we have also learned Python in the other modules and data analytics and other things, which were more specific to your domain of interest. So what is interoperability and why do we have to worry about that? Okay, again, so I'm not assuming anything. Some of you, I don't know, might have used JSON or XML. We will cover, we won't cover that, but we'll see how they're part of the interoperability. So what is interoperability? So interoperability is related to standards, integration, and interoperability. So we'll start with some familiar examples. Why is it important? So I will show you a small, short 5-minute video. I think that's a good explanation of the need for interoperability and some of the challenges. Even though it comes from the healthcare domain, some of the things that are brought out there are universally applicable. Then we'll go into some details about application interoperability, data usage interoperability, how FAIR principles affect interoperability. So what is interoperability? So we understand it in some of the things we do. It's an essential aspect of modern technology that allows diverse systems and electronic devices to communicate with work together seamlessly. So we buy a phone and then we already have a USB card, we plug it in, we buy a new device, we plug it into our laptop, our computer, and it works. You don't have to do anything about it. So this is the benefit that you get if interoperability is in place. So the goal of interoperability is to ensure that different technologies, applications, and digital platforms can collaborate to achieve a common objective without any data loss or misplacement, or without you have to develop some software for that or buy something else. In healthcare, the reason healthcare comes into picture is you can sort of visualize this very clearly in healthcare, because for a single individual in healthcare, you have so many different types of data that is generated. You go to your doctor, you have pathology, you have x-rays, you have EKGs, you have MRI, you have various uh, procedures that are done. Now, in order to assess and guide you with your health, it would be useful if all this information is available for the person looking at it. But even today, this is still not true. Even though we have made strides and advances. For example, I can say that, I belong to a particular network for healthcare, and all the doctors who are also in that network can see all my data in one place. But if I go to someone outside of the network, they cannot access my data. So they cannot make use of the complete data that is available. So interoperability to some extent we have, but we have not achieved the global interoperable status. So interoperability facilitate secure patient health information exchange among providers, patients, and third-party specialists. It reduces potential errors to enhance care. So that's why it's very important. There are different levels of interoperability. We'll come back to this a little bit later, starting with foundational to organizational, so different levels, and add certain things. So let's start with standards, integration, and interoperability. So we're all familiar with standards. We have heard of standards. So everyone has heard of standards, something set up or established by an authority as a rule for the measure of. So we know we have standards for weight, pounds and kilograms. We have standards for length, meters and yards, and various other things. Constituting or conforming to a standard, especially as established by law or custom or community, that's obeying the standard in various domains. So in the domain of software and technology, we have the famous IEEE standards, ANSI standards. ISO 9000 is very popular. A lot of you might have heard of it. ASCII standards, OGC standards. So the examples are, we know about USABC. We also know about the problems with that, right? If you have a you have a system that uses USB-C, you have the other end USB-A, you need a converter between them. SATA is a standard for disk transformation. SCSI is another one. XML is a software standard. HTML, we are familiar with SQL. So we also know the program. Interoperability means plug and play, means you don't have to do anything to get the benefit of the thing that you are adding, and you have to spend any time doing that. So following a standard has many benefits, supports multiple things with a standard interface to connect and interact without any additional effort. So think of it, we have a standard interface for a car, clutch, brake, and accelerator. Just imagine a situation if that were not the case. Every car had a different thing that it used for that, how difficult the life would have been. So even today, even with the press button start and other things, these are still the standards for how you are going to use a car. Not following a standard has implications. So we are familiar with, now it is changed. Apple insisted on having their own interface, which was not compatible with anybody else. But I think European Union forced it to change it to a standard interface. So from now onwards, all phones will have the same standard interface, for example, which is a lot more convenience. You don't need to carry converters. So we are familiar with that. Even today, electrical connection varies from country to country or region to region. So you have to carry converters and do that. So here is an example of what happened when standardization had not become popular. So there was a fire in Baltimore in 1904. And when the fire engines went there, 30% of the hoses would not connect because the hoses has one type of connection. The fire hydrants had a different type of connection, so they could not connect to each other. So this is the problem when you don't adhere to standards. So you might have heard of standard war. So certainly, there was a standard war between Betamax and VHS, for example. Finally, VHS won out. There are also, Sony had come up with some standards that they pushed for a long time, did not become mainstream. So these things are familiar. So why is this relevant to us? So our interest is in standards for using available data. So we are coming from the analysis side and we use data. So we have to worry about what is the corresponding thing for that. We want to share data. If we want to share data, what do we need to do? We want applications to interact without having to develop additional software, application and data integration, and interoperability. Standard is applicable to both data applications, and metadata. As we shall see, who creates standards? In entities such as IEEE, ANSI, OGC, consensus. So standard has to be a consensus-based things and something that would be useful to a very large community, and hence you are trying to enforce that. It also happens as evolution. You keep using certain things, find the utility of that, and then it becomes a de facto standard that everyone is comfortable with using. So a software standard is a standard or a protocol or other common format of a document, file, or data transfer accepted and used by one or more software. I took this definition from it, so it makes sense. So if there are two applications and you want to send data from one application to another application, how does this application interpret this data? Unless it knows what the data format is, what kind of things are coming. This was a situation for a long time, before XML and other things came about. You had to modify your applications to accept data from another application because you did not know what it was sending. Standards are critical to the understanding compatibility of hardware, software, and everything in between. Industry standards enable the essential elements of a computer and related infrastructure to work together. So standards allow technology to work seamlessly. That is your plug and play, and establish trust for smooth operation, provides a common language, makes interoperable components created independently. That's very important. Guarantees behavior that is well understood. So this is my favorite example that I give is, for those of you who are familiar, software development is a complex process and people have been doing it, but documentation is a very difficult task and it's rarely done. So people write software and leave it, and for the next person who is looking at such software, it's extremely difficult to understand what it does and why it was done in a particular way and how to modify. So this has been a real issue with software industry, and that's one of the reasons why software costs are extremely high. Java was one of the first languages that incorporated the notion of documentation into the language. Before that, none of the language, you could put comments in your language, in your code, comments are different from, documentation. So JavaDoc is not a standard, it's just a guideline introduced for the first time in a language, in a programming language for generating documentary. Remember, for generating documentation automatically. If followed, no need to write a separate document, which is not done at all most of the times, and that is why it is extremely difficult to do that. So how does Java do it? Here. So you need to sprinkle a bunch of things in as part of your code using some notation, some standard notation like @param, @return, @c, @since. Once you provide these things, when you run it through the Java documentation is automatically generated. So for example, I don't know whether it comes, whether this is complete. So here is the Java documentation for a Java code that is automatically generated. So this says here's the class. If you're familiar with Java, that will help. Then it tells you what are the attributes of this class, what is the constructor of the class, what are the methods of the class, what are the field details of the class, and so on and so forth. So this documentation is automatically generated if you provide appropriate things. So there is no need for a separate documentation. And this is an important thing. So, okay, here is something in a later vein. So why do we see so many standards? Situation, there are 14 competing standards. 14, ridiculous. We need to develop one universal standard that covers everyone's use cases. Yeah, now we have 15 competing standards instead of 14. So that's to some extent how it is. So also there is an old saying that says the good thing about standards is that there are so many of them. So kind of that's an oxymoron. If you have a standard, you are supposed to have only one of them, but not many of them. Okay. So that's about standards. So for integration, standardization is extremely critical. So following standards allow us to connect or integrate devices easily. And that is also true for software or data. However, we are dealing with not only devices, but data, software and applications. Although there are guidelines for software development, rarely applications that are developed independently can work with each other or exchange information without any additional support. So this is a big problem in the software development industry, and I cannot overemphasize that problem. Software costs are going through the roof mainly because many times people say, hey, it is too difficult to understand existing code. Let me start from scratch. So you start from scratch and redevelop the same thing and insert additional bugs and other things and testing, and that takes a lot of time. This requires integration of applications. So for application integration, the issue is how data is generated and consumed by the application. So it's always a producer consumer. One application is generating the data, another one is consuming it. So the generator needs to adhere to some standard. So the consumer can be aware of the standard and interpret it. Data can be generated in many formats. It can be in ASCII, it can be in binary, it can be a customized format, it can be in XML, JSON. Consuming data by other applications requires additional software to understand and interpret it. Without understanding and interpreting, you cannot deal with the data that you are receiving. This is usually done by adding appropriate new software in each application, which is an expensive process. And if the source decides to change their format a little bit, you have to redo this application again. So this may have to be done for each pair of applications. So this is a quadratic cost. So this cost increases quadratically as the number of applications come in. So this diagram is just to show that what are the different types of costs. This is one constant cost, log cost, linear cost, n log n cost. Here is the quadratic cost and others. So it increases as the number of applications. You can see that this line increases faster than these lines. That's what we are talking about. So software integration can be thought of as the process of connecting one software application with another, just like you connect two devices that have a common standard format, typically through their application APIs, as we call it. Once connected, applications can share data and provide updates to one another in or near real time. This could include integration with data repositories and different types of databases. So you can sort of connect them as if you are connecting two devices, and one application can consume data generated by another application and process and do whatever it's supposed to do. So here's an example. So you have points of sales data, typically known as market ware, collected by every vendor. You also have customer information that is available with the vendor. To understand the customer preferences, our customer, the above data may be in different form and needs to be accessed and processed together. One way is to do this through APIs and understanding the individual data formats. So this is different from multi-source data. So remember, in multi-source data, you are converting multi-source data into something common and using it. Here you are doing it at runtime. So kind of as and when the data is being generated. It is not that data is generated and stored somewhere and then fed into the next application. So what I want you to do is to take a look at this short video, I think which will to a large extent highlight or show you the interoperability. So let me get one second. Okay. Can you see this? I'm sorry. I don't know why I'm not able to expand it on full screen. Okay. Okay. I'm sorry. So even though it's a healthcare application, I think the components and what it is saying should be very clear in terms of what we need. So although it's from a healthcare, the principle explained in this video may be applicable to other domains, maybe in slightly different ways. So think of a speech given in UN General Assembly in a specific language. To translate this language to different languages, you need one interpreter for each language into which it is translated. Typically, that's integration. Alternatively, if there is a common language that everyone understands, then you can go to interoperability instead of integration. Integration is more like a pairwise thing. Interoperability is more one-to-many. So integration makes sense if you have a small number of applications to work together where the quadratic cost is not too high. So quadratic cost kicks in when the number of applications becomes large. Interoperability is preferred for large number of applications, less resources needed and scales better with different types of data being used. When a new application is added, it must only understand the common language. System or software developed for this system, the middleware or an agent. So how important is interoperability? So here is an example from the 70s and 80s. I know I was very intimately familiar with because we were studying some of this. So in the 70s and 80s, DoD, Department of Defense, was using literally hundreds of programming languages in its components, as well as multiple databases. Same data information was stored in several databases. Different attribute names were used, making it very difficult. Lots of research was done on schema integration, heterogeneous and distributed DBMS to overcome this problem. Lots of money was spent. The same data was misinterpreted many times, but represented using different attributes and levels of detail, sometimes inconsistently. Missions that are created in the DoD include resources from multiple units. So schema integration become very important. Heterogeneity, dealing with heterogeneity became very important. And that's one of the things that you can see as the difficulty. Take, for example, restaurant review systems is a good example. Each reviewer provides their own way of doing it. There has to be a common, so there is this Michelin standard that's very commonly used so that you can interpret it in the same way. So DoD initiated the development of a new programming language to be used across DoD. It was called Ada. Ada Lovelace was the first woman computer programmer, and it was developed and mandated for use in DoD. Ada is currently used across DoD as the only application development language. Unfortunately, it's not very widely used outside of DoD. DoD also funded the development of Oracle. So you can see that the impetus for development of Ada was the interoperability issue that was bothering them, or that is becoming an obstacle. Okay. We also routinely use Google Flights and other similar systems for exploring flights. This requires access to multiple independent data resources. So when it gathers data from multiple airlines, they don't come in the same format. They come in so many different formats, but they have to be understood in some way and then processed and given to you in a single format. So this is a very good example of interoperable system where it is reduced to a common format and interpreted and used. So that's one thing that we can use. So there are levels of interoperability I mentioned, so I may take another 10, maximum 15 minutes to wrap this up. So foundational is the most basic level of interoperability. Emphasis is on correct and secure data transmission. Structural involves ability to understand the data exchange structure. format and syntax. Seamless interpretation, it defines the standard format. Semantic levels offers data codification and common fundamental models, including standardized definitions and data elements from publicly accessible value sets and coding to help systems to have a common understanding of the meaning, that is the semantics of that. Organization is the highest level where you are able to interoperably use things for the whole thing. Now from open to fair, maybe I'll skip that because you will be learning a lot of fair principles in this. You already learned fair principles can apply to metadata as well. So let me go to. OK, so facilitating interoperability is typically done through data exchange formats. Using a standard or known data exchange format makes it easier for applications to facilitate. Support for known or agreed upon formats can be built into systems and typically known as markup languages. HTML, XML, RDF XML are used for this purpose. So common data exchange languages formats include XML, JSON, YAML, .csv, .tsv, tab separated, RDF, etc. We're already familiar with CSV and TSV files. These format files can be used directly in Python and other libraries used in Python like pandas to import data into frames. Metadata is still needed, semantic or at least structural. There has been a conscious move towards human readable formats as compared to earlier exchange of binary formats. So here are just one or two slides of what these formats mean. XML came about first. It's flexible, uses standard published by W3C. It's human readable and editable. Error checking using STDs, display using styles can represent hierarchies, kind of documents, tools available, but it's bulky in the sense payload to formatting ratio is high. Parsing and search query can be CPU intensive, but believe it or not, XML has been integrated into all the DBMSs because it was very popular at some point in time. So here is an example of the review XML format for review. I'll not go into the details. Extensively researched on its usage. Most DBMSs support natively. Most DBMSs support document object management model. For XML, DOM is created in memory. JSON, the main difference between JSON and XML is this is a language independent data format, but languages like Java provide native support to interpret JSON or provide APIs to handle JSON in the programming language, makes it easier to do. So here is a JSON example. Again, it is a hierarchical representation. You have attributes. You can give other attributes, first name, last name. They have JSON syntax rules. Data is in name value pairs. Data is separated by commas. Curly braces hold objects. Square brackets hold arrays. So it has a quite powerful vocabulary to express. I'll skip this because this is very old, very rarely used today. USGS has its own data formats that are used. USDT data services gets over 1 million hits per day. OGC standards are used for geospatial information interoperability. OGC conducted the USGS interoperability assessment to assess if OGC standards are implemented in USGS servers. So OGC advanced the following activities. So it gave a bunch of recommendations as to what each USGS compliant server should provide in order to make this data interoperable within the community of the people who are using it. So conclusions are that data by itself is of limited use unless it can be found, accessible, understood, and can be used meaningfully. Following the standards, using published data exchange formats with language support for them makes usage and analysis much easier. FAIR principles are one way to make data accessible and usable for millions of users, as is done by USGS. In fact, I think FAIR principles are more widely used, in my opinion, in USGS domain than even in computer science domain, unfortunately. Hence, it is critical that we understand the importance of standards, integration issues, and why interoperability is needed. In the next module, we'll discuss metadata and their provenance. So I'm going to stop here. Sorry, I have gone over by 10 minutes, close to 10 minutes. If you have any questions, I'll be more than happy to answer. Please take a look at the evening activity and see whether you can run it. And if you have any feedback, I'll be happy to hear next time we meet on Tuesday. So I'm going to have a small module. We are heading into a long weekend, so I wish you all a happy long weekend and hope you'll get recharged and come back to listen to 4 more days of the bootcamp. So any questions? Thank you. And if there are no questions, we'll see you next week. Have a good long weekend. See you.